There we are, finally on YouTube. Good evening. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with a regular Friday night broadcast coming to you from the studios of VK3 CSJ in Narre Warren South. And that little bit of musical interlude is actually the ASV lead-in or intro that's used on the YouTube and Facebook channels, which I usually run, but normally on the visual side of it with the Melbourne TV repeater and YouTube. But I pressed the button that allows it to go across on HF, so I thought, oh, well, why not? So if you like it, I'll stick to it. Anyway, very pleasant good evening to everybody, and we're broadcasting on prime frequency of 3541 kilohertz in the 80 metre amateur radio band, also simulcasting on 160 metres 1865 kilohertz amplitude modulation. There is no Melbourne TV repeater tonight. VK3 RTV, digital channel 1 and 2 in fact, are both down for maintenance until further notice, so there won't be any RTV transmissions tonight, unfortunately, which means there'll be less fan noise in the background. But we do have our YouTube channel running, and since I do have a lot of visuals tonight, no videos as such, nothing fresh from Tamitha Scove, even though she has done a report, but it goes for almost an hour. She does that every other week. She'll go right into super deep details about the solar weather, and all she does is compiles all her notes down to an 8 or a 10-minute video, which she makes as a general forecast at the beginning of the week. So if I'm lucky, I'm able to catch that before before the Friday night, and if it's reasonably fresh, I'll show you guys as well. Anyway, so like I say, we've got a few articles tonight. I doubt very much that I'll get through them all, but I'd rather have heaps to talk about here than not enough at all. We also have a Discord channel, or a computer window, whatever you want to call it, a chat window, that'll do. So if you want to join the chat window, it's a Discord setup, and you can find that on the ASV, the link to that on the ASV website underneath the Radio Astronomy tab. Click on the ASV radio broadcast link, and all will be revealed. The Discord channel is a little radio telescope icon that you can click on. So having a look at that, I can actually see quite a few folks there already. A very pleasant good evening to where am I started? Where's my announcement? Just there. So Richard VK3 VRS is there, and Martin VK7JH from Launceston has joined in. G'day Andrew from VK3 BQ, and I also see a little bit of an advert for astrophiz.com. He's out soon. Latest podcast. Anna Marie Delagado, maybe. Anyway, she's talking about machine learning and galaxy halos. So look out on astrophiz.com for the latest podcast, and I must try and run a few more podcasts of Brendan's as well. All right, bring that down to the bottom. Okay, we also have an email address, vk3ekh@gmail.com, vk3ekh@gmail.com, if you wish to send us a report on the video, on the broadcast in general. And I can already see a report from Stephen there, VK3 SPDX. No, sorry, it's Stuart, VK3A UAO, giving me a signal report, and from Andrew, VK3KIS, and Ian, VK3 Ian, VK5KKT, giving me good reports as well. So looks like I'm getting out reasonably well.
Yeah, 5-9, all bands, all frequencies. From VK3XL.
Okay, that's the local lad giving me a report there. All right, thanks, Mike. VK3XL. He's just no more than 500 meters away from me. So yeah, he has to disconnect antennas and everything like that to get a good signal from him. Anyway, all right. So at 6 past the hour already. I mustn't bump my keyboard or else things can go wrong. The Astronomical, for those who don't know, the Astronomical Society, founded in 1922 and has well over 1,600 members throughout Victoria and elsewhere. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy and to disseminate the knowledge of the science and to provide greater facilities for study and practice among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, the latter being held on a Saturday night. Meetings start right on the noggin at 8 p.m. at the Mulia Hall, the National Herbarium, Burwood Avenue in Melbourne, and which is not too far from the Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive, and from the surrounding streets. Admission is free. Visitors are most welcome indeed. The meetings usually finish at 10 o'clock. The aim is to finish up at 10, and if the sky is clear enough, you'll be able to go across to the library. As it says here, privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at Melbourne Observatory. Receipt of the ASV magazine Crux containing articles, news, observing notes and the like, and the free provision of the Astronomical Yearbook. Yes, access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meetings, depending on the weather, like I said before. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor managed by the Royal Botanic Gardens, and a recently restored photoheliograph are also housed at the observatory and are accessible to members as well. The Society also has a number of 200mm reflectors available for short period loan to members who wish to try before you might want to buy a telescope. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. There are a range of instruments available for members to use, the larger two only appropriate with appropriate training, which range from 300mm to 1000mm in aperture. There's also on-site a 8.5 metre radio fully steerable telescope, which members can access with involvement with the radio astronomy section. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral meteor, comet radio astronomy, computing, cosmology, astrophysics, historical studies, and research in astronomy in general. Contact details for various section directors are provided in the yearbook, but if you don't have the yearbook, because you may not be a member, all that information can be gleaned from the ASV website at www.asv.org.au. That's www.asv.org.au. And just look under the sections tab on the website, which opens up a page with about 20 separate sections, and each section links to a page which has more details and information about the section itself, and there should be also a email address which you can contact the section director and see how you can, as a visitor, just pop along to a meeting or to a Zoom meeting. And if it is of interest to you, then you can probably join in on another couple of the meetings. But the suggestion will be to, how about becoming a member of the ASV as well, which is all done by PayPal and easy peasy whatever, easy. All right, time is 10 past the hour. And we have another email that's just come in. It's from Stephen, VK3, who is it? Yeah, there he is. VK3 SPX, and at Burring Up, and he's a 30 over 9 signal over yonder. So very good. Hope that nobody got flooded out today. Certainly a lot of rain did fall. Yes, I'm just glad it all sort of petered out for a while. So I think the weekend should be relatively good, and all the puddles that are around here should eventually disappear, hopefully. Okay, so having said that, let's see what I've got next to go to. I might just go through the last part of these dates from Sky Notes from last week. I didn't go through them all. So today's date's the 7th. Yeah, I'll start off at, say, I'm not even sure where I finished off last week, but I think I'll kick off the 13th of September, October. Getting my months mixed up again. 13th of October 1773, the Whirlpool Galaxy M51A, 31 million light years away in the constellation of Canis Venatiae, is discovered by astronomer Charles Messier. And on the 18th of October 1967, Verona 4 is the first probe to analyse the atmosphere of another planet when it does so at Venus. On the 19th of October 1910, birth of, yes, that's a big name, birth of Subrahmanyan Chandrasekhar, who had major insights into stellar evolution and black holes. That was 1910. 24th of October 1998, Deep Space One USA probe was launched to test innovative technologies, including an ion engine, while visiting the asteroid Borrelly and comet Borrelly. On the 27th of October 1994, the first substellar object orbiting a star is found, a brown dwarf at Gliese 229. On the 29th, 1991, Galileo probe USA is the first to visit an asteroid, Gaspra 951, on its way to Jupiter. And final date, on the 31st of October in the year 2000, Expedition 1, first resident crew of the International Space Station arrived by a Russian Soyuz craft for a 136-day stay lasting until March 2001. The three-person crew, one American and two Russians, made the station fully operational and hosted three visiting US space shuttles and received two Russian Progress supply vehicles in that time. Expedition 1. So that's it for on this day, courtesy of Sky Notes, Tanya Hill at the planetarium. Thank you, Tanya. Okay, the time is 10:14 past the hour, and this is one article I held over from last week. It's a beautiful picture of Jupiter. Jupiter reaches its biggest and brightest in nearly 60 years. There's probably been a little bit of discussion of this on the astronomical networks. And I'll bring up this image of Jupiter. Quite stunning. There it is. So I'll watch your YouTube channel. For those that, I did mention it. For the visuals of tonight's broadcast, go to my YouTube channel, VK3 CSJ Live. So just type in VK3 CSJ in the YouTube search engine and look for the live symbol. and that will take you to it. You can also find the stream on the ASV website, the same page, ASV radio page, where you find the Discord channel 2 as well, I should say. So let's quickly go through this. This month is a great opportunity to see the giant planet at its best. And the picture here is the shadow. Ah, yes. The shadow of Ganymede falls across Jupiter in this image taken by NASA's Juno probe. The shadow seems especially large in this image because of how close the planet Juno, how close to the planet Juno was, something like 71,000 kilometers, or 1/15th the orbital distance of Ganymede. Swirling storm systems in the planet's belts and zones are also quite visible indeed in this gorgeous image. So Jupiter is an absolutely amazing planet. It's just so stunning, the things that go on there. All right, so I'll come back to live camera. Now, the article is saying that the editor's saying something here. I was just pre-reading that. All right, in 2022, Jupiter reaches opposition, the point in its orbit opposite the Sun as seen from Earth, which is on September 26. It's also the giant planet's closest approach to Earth since October 1963. And on the 26th, Jupiter will blaze at a magnitude of -2.9, making it the brightest star-like object until Venus rises shortly after sunrise. If you can't observe Jupiter exactly at opposition because of personal commitments or clouds or whatever, don't fret. You'll have plenty of time to see the king of planets while it's big and bright. At no time from July 20 through December 3rd does its magnitude dip below the -2.6. So if you have a decent pair of binoculars or decent telescope, certainly bring it out and take a look at Jupiter, and you should be able to get a reasonable size disk and the Galilean moons. On its opposition date, Jupiter sports an apparent diameter of 49.9 minutes, which is quite close to its greatest possible size of 50.1 minutes. And between, I'm getting distracted here, you might be able to hear that noise in the background. That's a weather balloon that's just been launched. Yeah, that's the data bursts from a weather balloon that's just been launched, and that's on 101.5, I think. Yeah, 401.5. So if you've got a receiver, you can tune to 401.5 and hear that annoying burst of noise, which I'll just go and turn down. So just hang on a sec. Sorry about that, ladies and gents. Yeah, so weather balloon tracking, it's rather interesting. There is a good website that you can go to look at that, which I might just let you guys know, interrupting the article for a second. If you go to sondehub.org, that's sondehub.org, that's sondehub.org, 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 and you'll find a map of the world with a lot of balloons that are floating around, and you can zoom in on Victoria and you can see where the latest balloons are up, and click on a balloon and the data from that balloon will be displayed on the left side of your screen. And like I say, a balloon's just been launched, and its beacon is let me click on that, is yes, 401.5. Sorry for that interruption. That was completely off base. Okay. Oh, dear me. Oh, g'day, Paul. Paul Gardner's sent me an email. Very good. G'day, Paul. And and Simon, who's watching on the YouTube side of things. Yeah, okay. Oh, all right, they're all up there at LMDSS. Okay, cool. And you're probably watching the YouTube channel as well. Okay, where am I? Back to this. Okay, don't fret. Yep. On its opposition date, Jupiter sports an apparent diameter of 49.9 minutes, which is quite close to its greatest possible size, which is of 50.1. And between the two dates above, its apparent size is at least 43 minutes. So, a second, sorry. So now is the time to set up the telescope, crank it up power, and observe Jupiter and its moons in their glory. Okay, look, there's a bit more to the article, but I'll leave that alone just there for the time being. You can find that article that is on the astronomy.com website. Jupiter reaches its biggest and brightest in nearly 60 years. That's all I really wanted to convey, was that Jupiter's in a position where it's fairly large to see, large-ish. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3 CSJ in Narre Warren South. Okay, swarms of swimming robots may soon explore alien seas. The concept of using robotic explorers to investigate subsurface oceans has been around for years, and a fresh shot of funding might soon turn the ambitious plan into reality. And there's a little sketch just here too, which I'll bring that up. There it is, a little cartoon kind of animation, impression. Illustration. NASA recently provided $600,000 in Phase 2 funding to investigate a novel approach for exploring the subsurface oceans of the solar system's icy moons. In our search for life beyond Earth, the ocean worlds, icy moons and deep seas have become primary targets. But these exotic moons have one problem. Their oceans, which astrobiologists think may host life, are trapped beneath miles of solid ice. So how can we explore these alien seas through such a daunting frosty barrier? Enter cryobots, probes designed to melt or dig through the icy crust of ocean moons. Cryobots have been under study for more than a decade, but now, as part of the Innovative Advanced Concepts NIAC program, NASA has awarded $600,000 in Phase 2 funding to investigate new approaches for searching for extraterrestrial oceanic life. The hope is that the funding will help scientists eventually deploy swarms of tiny swimming robots into the oceans of moons like Europa and Enceladus. Sending an armada of micro robots, each the size of a cell phone, is the brainchild of micro robotics expert Ethan Scalar and his colleagues at JPL and the Georgia Institute of Technology. The approach is known as Sensing with Independent Micro Swimmers, or SWIM. They just love their acronyms. SWIM is seen as the next step in cryobotic missions because now cryobots are seen as a viable solution for doing ocean access missions. Scalar says that we want to see what happens once you hit that ocean. What is the best way to explore it, he says. Most cryobots are designed to bore or melt through many miles of solid ice, eventually delivering a science package to the sea underneath. But their streamlined columnar profile leaves little room for science payloads and limits their mobility. If we want to explore at a distance from our entry point, we need a more capable swimming robot, Scalar says. And there's just another little graphic that they've got here, which I'll bring up. Okay, there's the graphic. So what we're seeing here is the sensing with independent micro swimmers swim concept. Illustrated here relies on dozens of tiny swimming subs which you can see in the center of the image, that are deployed in a subsurface ocean after a cryobot at the left burrows through the icy shell of a distant moon. Fortunately, engineers have come up with a solution, deployed dozens of these tiny submarines. Scaler and his team brainstormed a number of different ideas. He says, we looked at slightly larger tethered robots, he says. We also looked at passive floating sensor pods that you could deploy into the ocean's currents. We looked at tethered chain or sensor nodes, basically a long kite with the steerable elements to give you some mobility to steer in the downstream current. What we finally settled on were fully untethered and cell phone sized swimming robots. Without a tether, there is no danger of multiple robots getting tangled, and with multiple robots, engineers can start exploring some interesting behaviours. The swimming robots can flock together in a swarm or avoid one another and spread out to more efficiently map the surrounding environment. The delta-winged robot subs would be arranged in the cryobot-like overlapping pie slices. Scalar projects that projects that 48 of the explorers would pack into a single cylindrical cryobot. This packing plan is important because it means the miniature submarines could all fit within a space designed for one science instrument. Notionally, a 5-litre space or some 0.2 cubic feet. If a cryobot is designed to carry 3 or 4 science instruments, 48 micro swimmers could or would take up only one experiment's worth of space. Each craft would have a lifetime of roughly 1.5 to 3 hours, enough time to chart physical or chemical gradients in the water column, as well as measure the region's salinity and temperature and even search for signs of active life. The small subs would be deployed in a few at a time to investigate ocean dynamics at different times of the day and night. In Search for Life, variations that follow the day-night cycle can serve as strong biomarkers or clues to the presence of life. So there's a bit more to that article, but if you want to follow that also, you can go to astronomy.com under the news tab and search for swarms of swimming robots may soon explore alien seas. And that's dated the 28th of September. You're tuned to ASV Radio VK3EKH, coming to you from the studios of VK3CSJ in Narre Warren South. That's my radio announcing voice. I've got the headphones on, it sounds really cool. Alright. Next. What is next? Oh, yeah, okay. Published a day ago. That is 1 day ago, not a day ago. Sorry. All right. Where am I? There's a picture here too. Where is my image? There it is. Oh, it's slightly out of sequence here. Anyway. Okay, back to the article briefly to kick it off. Mysterious reflections on Mars might come from something stranger than water. Scientists hoped it was a lake under the ice, but it may just be a mirage. So this image, which is this one, here. This is an image captured by the NASA's Mars Reconnaissance Orbiter, or layers of ice near the red planet South Pole. Mars Reconnaissance Orbiter. I always trip over that word. Scientists revisiting a mysterious signal from the South Pole of Mars have suggested a new potential explanation, and it doesn't bode well for hopes of finding liquid water on the red planet. In 2018, scientists using data from the European Space Agency Mars Express Orbiter's Mars Advanced Radar for Subsurface and Ionosphere Sounding, that is, which is MARSIS, MARSIS, Struth, instrument announced that they observed a radar signal that could be interpreted as evidence of liquid water. That signal, a strange bright reflection, came from the Martian South Pole in a region known as the Ultima Scopulae, Researchers investigating the reflection now suggest that the signal didn't come from the ice itself or even from liquid water, but from underlying geological layers made of minerals and frozen carbon dioxide. In particular, it turned out that the thickness of these layers, rather than what they were made of, creates the unworldly reflection. Nothing unusual for Mars. On Earth, dazzling reflections like this often come from liquid water, for example, subglacial lakes like Antarctica's Lake Vostok, which has been lying under more than 3 kilometers of ice for millions of years, causes bright radar signal like that found on Mars. However, just because it's possible for something like this to have also occurred on Mars doesn't guarantee the presence of liquid water. I'll just come back to live camera. Right. Where was I? Previous studies. When I do that, I always lose my spot. Because this is an immense amount of carbon dioxide frozen in the Martian South Pole, Cornell University's planetary scientist and lead author of the research, Dan Leach, was sure to include layers of this ice in his simulations. And one simulation in particular with a layer of carbon dioxide ice below the water ice revealed that separation of thickness of layers determined the strength of a reflection. Previous studies by Lalich worked on also found that the certain minerals could also conjure a reflection like this. He believes that even layers of the red planet's dust-obscured ice are capable of it. Either way, no liquid water is necessarily created or create the reflection in question. He says, I could have used rock layers or even particularly dusty water ice and would have gotten similar results. This point of the paper that was written up is really that composition of the basal layers less important than the layer thickness and separations. The new research doesn't mean that there is no chance of liquid water existing somewhere on Mars, however. None of the work we've done disproves the possible existence of liquid water down there. We just think that the interference hypothesis is more consistent with other observations. He says, I am not sure anything short of a drill could prove either side of the debate, definitely right or wrong. Whether under a glacier or deep beneath the planet's scorched reddish surface, water and possibly traces of life may still be lurking somewhere, he says. So that article, Mysterious Reflections on Mars Might Come from Something Stranger Than Water, published a day ago, and that's on space.com. You're tuned to... Okay, what time is it? Oh, yeah. I came across this little report. This is actually not necessarily a new report, but I just started reading it. And it's space.com. It's an article off space.com. So my apologies for the morbid way this article might sound. Anyway, let's get through it because I thought it was interesting. It says interesting if you have a forensic outlook on things. Death in space. Here's what would happen to our bodies. Do I have a picture for this? No, it's just the article. Okay. As space travel for recreational purposes is becoming a very real possibility, there could come a time when we are travelling to other planets for holidays or perhaps even to live. Commercial space company Blue Origin has already started sending paying customers on suborbital flights, and Elon Musk hopes to start a base on Mars with his firm SpaceX. This means we need to start thinking about what it will be like to live in space, but also what will happen if someone dies there. After death here on Earth, the human body progresses through a number of stages of decomposition, and these were described as early as 1247 in a song CI's The Washing Away of Wrongs, essentially the first forensic science handbook. First, the blood stops flowing and begins to pool as a result of gravity, a process known as Rigor Mortis. Then the body cools to Rigor Mortis, and the muscles stiffen due to uncontrolled buildup of calcium in the muscle fibers. This is the state of rigor mortis. Next, enzymes, proteins which speed up the chemical reactions, break down cell walls, releasing their contents. At the same time, the bacteria in our gut escape and spread throughout the body. They devour the soft tissues. Perforation and the gases they release cause the body to swell. Rigor mortis is undone as the muscles are destroyed. Strong smells are emitted and the soft tissues are broken down. These decomposition processes are the intrinsic factors, but there are also external factors which influence the process of decomposition, including temperature, insect activity, burying or wrapping a body, and the presence of fire or water. Mummification, the desiccation or drying out of the body, occurs in dry conditions which can be hot or cold. In damp environments without oxygen, a dipocori formation can occur, where the water can cause the breakdown of fats into a waxy material, and that's what that word means. A dipocori. No, it's dipocosur, something like that. Anyway, that word means fats into waxy material and grimy stuff through the process of hydrolysis. This waxy coat or coating can act as a barrier on top of the skin to protect and preserve it. But in most cases, the soft tissues will ultimately disappear to reveal the skeleton. These hard tissues are much more resilient and can survive for thousands of years. Halting decomposition. So, what about death in the final frontier? Well, the different gravity seen on other planets will certainly impact the Rigor Mortis stage, and the lack of gravity while floating in space would mean that blood would not pool. Inside a spacesuit, rigor mortis would still occur, since it is the result of the cessation of bodily functions, and bacteria from the gut would still devour the soft tissues. But these bacteria need oxygen to function properly, and to limit supplies of air would significantly slow down the process. Microbes from the soil also help decomposition, and so any planetary environment that inhibits microbial action, such as extreme dryness, improves the chance of soft tissue preservation. Decomposition in conditions so different from Earth's environment means that external factors would be more complicated, such as with the skeleton. When we are alive, bone is a living material comprising both organic materials like blood vessels and collagen, and inorganic materials in a crystal structure. Normally, the organic component will decompose, and so the skeletons we see in museums are mostly the inorganic remnants. But in very acidic soils, which we may find on other planets, the reverse can happen, and the inorganic component can disappear, leaving only soft tissues. On Earth, the decomposition of human remains forms part of the balanced ecosystem, where nutrients are recycled by living organisms such as insects, microbes, and even plants. Environments on different planets will not have evolved to make use of our bodies in the same efficient way. Insects and scavenging animals are not present on other planets in our system. But the dry desert-like conditions of Mars might mean that the soft tissues dry out, and perhaps the wind-blown sediment would erode and damage the skeleton in a way that we see here on Earth. Temperature is also a key factor in decomposition. On the Moon, for example, temperatures can range from 120 to minus 170 degrees Celsius. Bodies could therefore show signs of heat-induced change or freezing damage. But, the author says here, but I think it is likely that the remains would still appear human, as the full process of decomposition that we see here on Earth would not occur. Our bodies would be the aliens in space. Perhaps we would need to find a new form of funerary practice which does not involve the high energy requirements of cremation or the digging of graves in a harsh, inhospitable environment. Full stop. Well, I hope you found that interesting. This is VK3 Echo Kilo Hotel. That article also found on space.com called Death in Space. Here's what would happen to our bodies. Most taining. Okay, time is 19 minutes to 11. Just looking at the chat window. No more emails have come through. Oh, Remus has joined the chat window. Kim is there, VK5 FUSC. G'day, Kim. And Andrew's put up the satellite tracker, the balloon tracker. Good on you. Thanks to doing that, Andrew. Excellent. That's on the chat window. Discord. Alrighty then. Now our next article, which we should be able to squeeze in here. There's a few pictures here. Mars is littered with thousands of pounds of trash from 50 years of robotic exploration. Discarded pieces of landing gear, crashed spacecraft, wear and tear have produced a lot of debris that is now scattered around the Martian surface. And there's the first image that I'll bring up. There it is. That is the rovers on Mars frequently come across debris like this heat shield and spring from their own or other missions. So if you're watching YouTube channel, you can see it's the heat shield, and there is a spring in the foreground here, and that's something you wouldn't normally find on the Martian surface. So continuing on. People have been exploring the surface of Mars for over 50 years, according to United Nations Office for Outer Space Affairs. Nations have sent 18 human-made objects to Mars over 14 separate missions. Many of these missions are still going, but over the decades of Martian exploration, humankind has left behind many pieces of debris on the planet's surface. Now, the author who's written this has said that I am a postdoctoral research fellow who studies ways to track Mars and Moon rovers. In mid-August 2022, NASA confirmed that NASA's rover Perseverance had spotted a piece of trash jettisoned during its landing, and this time a tangled mess of netting. And this is not the first time scientists have found trash on Mars, and that's because there is a lot there. And here's another image. I'll bring up. There it is. Okay. So, and that image you're seeing there is. It says here, all spacecraft that land on Mars eject equipment like this protective shell on their way to the Martian surface. So you can see that the protective shell has literally exploded, hitting the ground, and has just left a complete debris field all the way around it. So they say here that debris on Mars comes from three main sources: discarded hardware, inactive spacecraft, and crashed spacecraft. Every mission to the Martian surface requires a module that protects the spacecraft. This module includes a heat shield, or when the craft passes through the planet's atmosphere, and a parachute and landing hardware so that it can land softly. The craft discards pieces of the module as it descends, and these pieces can land in different locations on the planet's surface. There may be a lower heat shield in one place and a parachute in another. When the debris crashes to the ground, it can break into smaller pieces, as hardened during the Perseverance rover landing in 2021. These small pieces can be yet blown around because of the Martian winds, and there's a picture of that just here too. This one. Perseverance rover came across this piece of netting on July 12, 2022, more than a year after the landing on Mars. So we are making a royal mess of Mars even now. A lot of small windblown trash has been found over the years, like the netting material found recently in the picture there. Early in the year, on June 13th, Perseverance rover spotted a large shiny thermal blanket wedged in some rocks, 2 kilometres from where the rover had landed. And both Curiosity in 2012 and Opportunity in 2005 also came across debris from their landing vehicles. And this next image here is the European Space Agency's Sharapari lander crashed into the surface of Mars in 2016, as seen in these photos. The crash site captured by NASA's Mars Reconnaissance Orbiter. So you can see it's a bit of a blurry image, but you can basically see that something has crashed and it created a little bit of a debris field in the process of doing so, which is a nuisance factor. So, having said that, dead and crashed spacecraft, the 9 inactive spacecraft on the surface of Mars make up the next type of debris. There's 9 of them. These craft are the Mars 3 lander, the Mars 6 lander, Viking 1 lander, and Viking 2 lander, and the Sojourner rover. The formerly lost Beagle 2 lander, the Phoenix lander, the Spirit rover, and the most recently deceased spacecraft, the Opportunity rover. Most intact, these might be better considered historical relics than trash. Wear and tear take the toll on everything on Martian surface. Some parts of the Curiosity's aluminium wheels have broken off and are presumably scattered along the rover's track. And there's a picture of that as well. There it is. So as you can see there, the parts of the rover's wheel has actually broken, and as the article says, it's probably scattered amongst the path that the rover's been travelling. Crashed spacecraft and their pieces are another significant source of trash, as at least 2 spacecraft have crashed, and the additional 4 have lost contact before or just after landing. Safely descending to the planet's surface is the hardest part of any Mars landing, and it doesn't always end well. When you add up the mass of all spacecraft that have been sent to Mars, you get about 22,000 pounds, or 9,979 kilograms. Subtract that weight of the currently operational craft on the surface, some 2,860 kilograms, and you are left with 7,119 kilograms of human debris on Mars. Good grief. So why does it trash matter though, you might ask? Today, the main concern scientists have about trash on Mars is the risk it poses to current future missions. The Perseverance teams are documenting all debris they find and checking to see if any of it could contaminate the surface the rover is collecting. NASA engineers have also considered whether Perseverance could get tangled in debris from landing, but have concluded the risk is low. The real reason debris on Mars is important is because it because of its place in history. The spacecraft and their pieces are early milestones of human planetary exploration. Only humans can make an excuse like that. All right, this is VK3 Echo Kilo Hotel ASV Radio, VK3 EKH, and coming back to the camera. All right, we've got less than 10 minutes, and I think I can squeeze in a couple of more articles. Okay, a little bit on DART. DART impact gave asteroid Dimorphos a debris trail thousands of miles long. And have a look at this picture, although it doesn't really look all that great, but when you realise what it is, come on, bring it up. There she blows. Okay, so what you're seeing there is the aftermath of the DART collision with the asteroid Dimorphos, as seen by SOAR telescope, SOAR. A new stunning image shows that 2 days after the NASA's double asteroid redirection test, DART, spacecraft slammed into the asteroid Dimorphos. The spacecraft had grown a tail of glowing debris extending thousands of miles. The comet-like tail is made of dust and debris was blasted away from the surface of Dimorphos, part of the double asteroid system, by intentional impact of DART, the first mission designed to test whether such a collision could divert a hypothetical asteroid threatening to hit Earth. Dimorphos' new tail was imaged by astronomers Teddy Carretta from the Lowell Observatory and Matthew Knight from the US Navy Academy using the 4.1 meter Southern Astrophysical Research, or SOAR, telescope. At the National Science Foundation funded NORLab's Carrillo Tello Inter-American Observatory in Chile. It is amazing how clearly we were able to capture the structure and extent of the aftermath in the days following the impact, Carretta said in a statement. Observing the ejected material could allow scientists to better determine the nature of the surface of Dimorphos by revealing just how much material the collision from DART ejected, the speed at which the material was launched, and the size of the ejected particles. This knowledge could ultimately help space agencies like NASA protect Earth from asteroid impacts, because a better understanding of asteroid structure and composition helps scientists model how best to divert them. The material in the dust trail was significantly initially ejected on September 26 when DART hit Dimorphos, forming a cloud around the asteroid. A tail-like structure formed when radiation pressure from the sun pushed the debris away from the body of the asteroid, just as it happens when tails of comets, as they approach the sun, form from the distant reaches of the solar system. The SOAR image shows Dimorphos' new feature extending from the center of the image to the right-hand edge of the image. Using Dimorphos' distance from Earth at the time the image was captured, the astronomers estimated the tail was around 10,000 kilometers long. Okay. Just having a quick scan of the rest of that because it's nearly finished. Yep, I'll leave that. All right, so there it is. Very, very interesting tail there created by the DART impact on Dimorphos. So most interesting indeed. Okay, now we've just got less than about 5 minutes, so I'd like to try and finish on time. The next article was that one, and that's a bit too long, so I'll leave that till next week. Are we alone? The search for intelligent life in the universe. And NASA's, it's a bit lengthy. There's probably 5 minutes in that. But what I'll do is NASA's Juno. This is 19 hours ago, so this is pretty current. NASA's Juno spacecraft snaps the most detailed view of Jupiter's icy moon Europa. Let me bring that picture up. Alrighty then. So I'll just briefly read the first few paragraphs. The landscape in the image is only illuminated by Jupiter's night glow. NASA's Jupiter exploring Juno spacecraft captured its most detailed image of the ice-covered ocean-bearing moon Europa, which scientists think is one of the likeliest places in the solar system to host extraterrestrial life. The image taken just last week during Juno's close flyby of the mysterious moon reveals a frozen surface crisscrossed by ridges and grooves, as well as the plethora of unusual features. Dark blotches strain the ice in the upper right corner of the image and to the bottom right of the center, which scientists believe may have been produced by material bubbling up from the depths of Europa's ocean and erupting into the ice. The image, which depicts an area 150 kilometers long and 200 kilometers wide, kilometers, also reveals a strange depression shape like a musical quarter note sprawling for 67 kilometers from north to south and 37 kilometers from east to west in the lower half of the image. The tiny white dots scattered all over the image, scientists said in the statement, are signatures of the penetrating high-energy particles from the severe radiation environment around the moon. Yeah, I'd like to read the rest of that out, but you can catch up with that on space.com as well. And that's, like I say, that's published 19 hours ago, probably 20 now, at space.com. NASA's Juno spacecraft snaps the most detailed view of Jupiter's icy moon Europa. All right, now the next thing I've got here is another brief thing. Oh yeah, okay. Artemis 1, just a little bit on Artemis 1. It's nothing, just a couple of paragraphs, I think. NASA's Artemis 1 moon mission will be agency's first big step toward returning astronauts to the lunar surface. Artemis 1 will be the first test flight of the agency's new space launch system, Mega Rocket, and the Orion crew capsule. The SLS rocket will launch the uncrewed Orion spacecraft on approximately a 42-day mission, during which it will orbit the moon before returning to Earth. Artemis 1 is now currently scheduled to launch no earlier than mid-November, between November 12 and 27, from Launch Complex 39B at NASA's Kennedy Space Center in Florida. So we're looking at a next window in mid-November, November 12 to somewhere between November 12 and 27. So we just got to hang in there a little bit longer. Okay, now finally we're getting on to space weather. Now, I've got a couple of images here. This is the latest sunspot number and also the radio flux, because the sunspot number and the radio flux measurements mirror each other perfectly well. And actually, I may not be able to bring that up. I wonder if I can. Hang on a second. I've got to play with this. I've got to go to there and go to there. I use vMix to get myself around. Which one is it? I didn't get this ready to go. No, that's not it. Bear with me. I just want to bring up. Yeah, see, I forgot to do that. Hang on a sec. Just got to work out which one. It's this one here. Yeah, that should be it. No, this is VK3EKH, the Astronomical Society official station of the Astronomical Society of Victoria. That should be it, but maybe yes, no, yes, that's not it. Struth. No, it's gonna make me muck around too long for it. But what I could do, which might be a little bit quicker, is just take a quick screenshot of this. Where is it there? Okay, just hang 10 with me, ladies and gentlemen, while I take a quick screenshot of these two charts so you can see what it is that we're looking at. Save that in there. Hang on a sec. Oh, it's telling me that there's something else in there. So I just put a 1 on that, capture 1. And save that. There it goes. Back into vMix. Go to add input. Go to image. Go to browse. and where thou is it? All files. Oh, where did it go? Well, wouldn't it bother you? Alright. I don't know what's happened to it. I did save it, and I can't see it now. Well, there it is. I'll have to do it all again next week, so you can see, because there won't be a whole lot will change between now and next week as far as the solar cycle goes. But I just wanted to show you where we are on the peak of things, and if for some reason that didn't go where I thought it would go. What a nuisance factor. All right, we won't worry about that. We'll continue on the solar weather report. All right, there it is on my screen here, right in front of me. Spaceweather.com. The solar wind is currently at a speed of 452.1 kilometers a second at a density of 5.15 protons per cubic centimeter. The current disk of the sun looks like this. See how easy this is when you get it all prepared. There are 1, 2, 3, 4, 5, 6 sunspots on the disk of the sun as we speak. And the space weather indicates that there is a minor geomagnetic storm watch. A CME is heading for Earth, and it could graze our planet's magnetic field on October 7 and October 8. The storm the storm cloud was hurled into space on October 4 by an erupting filament of magnetism in the sun's southern hemisphere. Gaps in the coronagraph data make it hard to know for sure where the CME is heading, so this is a low confidence forecast. If a glancing blow does occur, it could spark a minor G1 class geomagnetic storm, and therefore look out for aurora alerts. And the only other image I've got here is the aurora australis over the South Pole. That is the current auroral oval over Antarctica, which is stretching out towards Tasmania. There's a possibility of seeing the auroral glow from Tasmania, maybe from Heathcote as well. But there is certainly a good glow happening over the South Pole as we speak. Okay. And the last thing that I was going to mention here out of spaceweather.com, which is going to be of interest to us astronomers, Blue Walker 3 update. The AST, Space Mobile's controversial Blue Walker 3 satellite, has been orbiting Earth and communicating with ground stations for nearly a month. It is stable, following the correct orbit, and taking great pictures of the planet below. For now, the next step, unfurling its enormous antenna. This could happen little more than a week from now. Designed to supply 4G cell phone signals from space, Blue Walker 3's antenna is huge, 64 square meters, of the size of a squash court. I've got a picture of it here. Bring it up. Okay, there it is. 64 square meters, the size of a squash court. This flat surface, orbiting 500 kilometers above Earth, will reflect a lot of sunlight, which could make the satellite extremely visible to observers on the ground. Flares from the Blue Walker 3 might even be brighter than Venus, outshining everything in the night sky except for the moon. While there's only a single satellite for now, AST Space Mobile plans to launch more than 100 larger satellites called Bluebirds, doubling the size of Blue Walker 3. The Bluebirds would appear even brighter in the sky. Hence the controversy. Astronomers worry that these satellites would interfere with deep sky observations by ground-based telescopes. Starlink satellites are already streaking images and ruining exposures. Absolutely. Blue Walker 3 and the Bluebirds could be 10 to 100 times brighter. We will soon find out. Observers have been watching Blue Walker 3 since it launched on September 10. So far, it is no brighter than a dim third magnitude star, but its brightness could change dramatically when the antenna reaches full size. AST Space Mobile says we plan to unfold the ray in the second half of October, so stay tuned for sightings. Not impressed with that story at all. As of October 7, 2022, there are 2,298 potentially hazardous asteroids, plus Dimorphos. All right, that's it. We shall conclude our broadcast for tonight, and thank you very much for watching on the YouTube channel. A very pleasant thank you to everybody who's emailed me an email. From Stuart VK3A from Stuart VK3UAO, Andrew VK3KIS, Ian VK3VIM, Stephen there from VK3SPX, and Simon, I'm not sure your call sign, and Paul. I don't think you've got a call sign, but you should get yourself a license. And Ian Westerland. And that's Ian, yes. All right. So thanks, guys, and everybody up there on the chat window. And look at that, Mr. BQ has got the solar cycle up there on the BQ page, on the Discord channel. There you go. So that's the solar cycle. So if you're looking at the Discord channel, the chat window, you can see it's the solar cycle. What I was going to show was the solar cycle together with the radio flux cycle, which pretty much mirror each other. So everybody up there on the chat window, Kim, Remus, Andrew, and the other Kim, and yep, that's about it. Martin, VK7JH, and that's it. Richard as well, VK3VRS. All thanks for coming up on the chat window. And thank you for watching the YouTube channel. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Concluding transmissions now on the medium wave service on 1865 kilohertz AM. There will be a quick callback conducted on 80 meters only on 3541 kilohertz. So standby stations on 80 meters. This is VK3 EKH concluding transmissions. Like I say, for more information about the Astronomical Society of Victoria, just go to the website at www.asv.org.au, and all will be revealed. A very pleasant good evening to everybody on that's been listening on 160 meters. This is VK3 EKH concluding. Standby on stations on 80. Oh, noise. I've got noise in my headphones all of a sudden. I'll turn that off, and I'll go to... Actually, I won't use the headphones for 80. I don't usually wear headphones. Oh, that's so weird. I don't usually wear headphones while I'm doing the broadcast. I just left them on. So there it is. But anyway, I shall now call in stations on 80 meters and see who is there wishing to call in. This is VK3 EKH listening on 3541. Okay, we've got VK3JR, VK3VIN, VK3TJS, and I think VK3KT. Not sure on that, but it's a bit of a weak signal. VK3SPX. Is there any other stations? Yeah, there's another station, very, very weak. Try again. Yeah, VK3 something. I can't quite catch the call. Try again. Super week. Is anybody else able to copy the station? Was that VK2 XIC? Ah, yes. Okay. All right. We know VK2 XIC. I hope you're watching the YouTube channel. All right. To the top of the list, VK3JR. G'day, Frank. VK3EKH.
Very good broadcast as usual. Lots of interesting stuff. And he survived. I haven't got anything special. I've given up doing counting exoplanets because I think the count's wrong. I think NASA has a much higher count. However, all the bands ticking over very nicely. And there's lots of DX there. There'll be missions tonight. Steve will be on. And that's about it. And back to tomorrow on 60 meters. Great. Thanks for doing it. VK3EKH and VK3JR.
Oh, wrong button. VK3JR, VK3EKH. No worries there, Frank. And yeah, I'll